What's up guys, in today's video I'm going to teach you and I'm going to show you how to create a queue in C. You are going to see that is something truly very simple and yeah, let's get to that. So, if you have seen my previous video in which I talk about a stack, a queue is something very similar. So if you remember, we have, for example, this. And let's think that this is the memory. But first of all, a queue is a data structure which follows the FIFO method, which is that the first element that went in the queue is going to be the first element to come out of the queue. So for example, let's say that we push, which is an action of the queue, push a 1. So this one is going to come here to the queue. And by the way, a queue in memory is just a simple array. So here, for example, we have the 1. Let's say that now we push a 2. So here now we have the 2. And let's say that finally we push a 3. So here we have a 3. But now let's say that we try to pop. And pop is another action that the queue has. When we try to pop, we just simply want to take an element, but which element are we going to take? If you remember, I said that the queue follows the FIFO method, which is the first in, first out. So which was the first element to come in? It was this one, the 1. So whenever we want to pop, what we are going to do is that we are going to take the first element which was introduced by the push function. So here, if we push the 1, well, if we pop the 1 and now we want to pop another element from the queue, the next element that is going to be popped is the 2, and then finally the 3. So that's the thing about the queue, and it's truly very simple. But enough talking, let's go to Visual Studio Code and let's implement this. It's truly very simple. First of all, we are going to create a queue.h file in which we are going to include some useful libraries such as the standard library and such as a standard input and output. Now we are going to declare the structure, but yeah, in the .c file we are going to define the structure in another way. So here we are going to give it a normal name. So here we're going to say like typedef struct. This structure, the queue is like the underscore queue is going to be defined in the .c, but here we are going to call it like this, queue. So it's much more simpler. So now we need to define the primitives, the functions that are going to allow us to operate with the queue. So the first one is queue. We are going to receive a pointer to the queue, and this function is going to be the one which will initialize a queue. So it's going to allocate memory for us in the system for the queue. The next function is the push function. So in this push function, we are going to receive the queue in which we want to send the element, and the next thing that we are going to do is to put the value. We are going to deal with integers, so we are going to create a queue of integers, but you could create a queue of anything you want. But in this case, it's going to be, the elements are going to be integers. The next thing that we need to do is to pop. So we are going to define the pop function that receives a queue in which we want to pop, and it doesn't receive anything else. But since I said that we are going to only deal with integer values, the thing that we need to receive is an integer. So the next thing that we need to do is to destroy the queue. So let's put here queue destroy, and we need to receive the queue that we want to destroy. Finally, let's put here queue print, so we can see how the queue looks. And we have finished with this. So now the next step is implementing the .c file in which we are going to put all the logic behind the queue. So let me copy this. Let's come here. Let's create a new file, queue.c. And first of all, we need to include the queue.h, And yeah, let's copy this here. But now we have to define the structure that I told you before, the underscore q. So for that, we are going to do it very simple. It's going to be the same as the stack. So we are going to have here an array that is going to contain the elements. We are going to call it items, so it is a pointer. You have to know that. And now we are going to create another variable in which we are going to store the number of elements that we have. So here we are going to put num items. If you are wondering why did I create it as a short, it doesn't matter. Like, it's the same, but this variable is going to only have, like, it's not going to contain as many numbers as an integer. This one is smaller, but yeah. Whatever. So let's implement the first function, which is the qini. We have to initialize here the q. And what is the first thing that we have to do? We are going to create a variable, a pointer q, initialize to null, and this variable is going to be the one that we are going to return, but we need to initialize it. So how do we do this? The first thing that we need to do is that we need to say that the q variable is equal to malloc to allocate memory, and here is asking us for the size. So we are going to say that we need the size of a q, and it is as simple as this. So if you have seen here, this function returns a void pointer. So we need to do a cast. So we are going to put here a cast. And technically you don't need to do the cast, but I'm used to do this, so I prefer to do it. But with the void pointer, I think that you don't need to do it, but yeah, anyways. So the next thing that we need to do is to check if the operating system gave us the memory. So for that, we are going to put this q equal null. We are going to return null. So in this case, that q is equal to null, it means that the operating system didn't give us the memory, and we are returning null. So the next thing that we need to do is to initialize the elements of the q. So how do we do this? We need to access the elements. How? Like this. So we put here items. This is going to be null because it's a pointer, and at the beginning it's not going to have anything. And finally, we are going, well, not this, we need to initialize the number of items to 0. So at the end, we are going to return q, the variable in which we have the q. So as you can see, very, very simple. So now the next thing that we need to do is to push elements. And how do we push elements? Let's come here again. And do you remember what we did here? It was very simple. So for example, push 1. Let's say that we have this here again. What we are doing is that, in this case, we don't have an array initialized, but what we are going to do is that we are going to be super efficient. So whenever we push a 1, we are just going to allocate memory for this one. So there's no space for anything else at the moment. But whenever we call push 2, we are going to create more memory, and we are going to introduce the 2. And whenever we put the 3, we push the 3, we are going to create more memory, and we are going to put here the 3, and let me put here the 2. Oh my god. But yeah, the thing is that there's only a space now for 3 elements, no more. So if we keep pushing, we are going to make it bigger, and if we pop, we are going to delete elements from here. But yeah, let's continue and let's do that. So how do we do this? First of all, we need to know that we are going to use the function realloc because it's super useful for this. So we have to take into account that we have this variable, which is the number of items. So let's say that we want to push an element into an empty queue. We don't have any item. This is set to 0. So what we can do is that, okay, the array of items is going to be equal to reallocate the memory here. It's asking us for the pointer, which is this one, and we need to set now the new size. So the new size is going to be, okay, the number, node s, sorry, q, the number of items, let me put this q, yeah, the number of items plus 1, because remember here we have a 0, so one element by the size of int. And why int? Because as I said before, this queue is going to contain int elements. So this is very, very, very cool. So now if we have 0 elements, we are going to allocate memory for 1 element, so we can introduce that one that I talked about before. If we have one element, we are going to reallocate the memory to have two spaces so we can introduce the two value. So let's continue and let's do all this. So first of all, the operating system may not give us the memory. So in this case, we are going to check here. If QItems is equal to null, it didn't give us the memory. We are going to put return. So the next thing that we need to do is to add the element, but where do we add the element? As you can see in the array, whenever we add a space of memory, we add it here at the end, at the last space of memory. So we are going to do this. How? We need to take into account one thing. That is that, for example, now we have an empty queue. And the value of the num items is 0 because there is no elements. But we created a space for one element. So this value, which is 0, is actually the index of the empty space. Because if you remember, the memory, the addresses in the indexes of the arrays in C are like this. So this is the 0, this would be the 1, then the 2, etc. So the 0 index actually is pointing to the empty index of the queue. So what we can do is that we can use this number, this same number, and say, okay, from QItems, since now we have one space, I want to access to that space, which is this one. So now we are saying that at this point in this place, I want to store the value. So this is okay. So again, let's say that now we have one element and we want to push another one. What is the value of QItems at this point? Well, of QNum items at this point, it's going to be 1 because we have one element. So it is actually pointing to the place in which we are going to store another element. So that's very cool. And you may be wondering, hey, but why is it 1 if before was 0? Because now we are going to increase that value. We are going to say that the number of items is going to be increased by 1. So whenever we introduce the value, we are going to increase the number of items. So what is the next thing that we have to do here? We need to pop an element, and this one is a little bit trickier. So first case, we may have that the queue is empty. And what do we do in an empty queue? In this case, since this is a very simple example, what we are going to do is that we are just going to return 0. But it is very useful to have this num items variable because it is allowing us to know how many items do we have in the queue. So if we don't have any items, we are going to return just -1, and that's it. But we may have items, and what do we do now? First of all, let's store the value because we want the value. Let's create a variable called first, because remember, we are going to use the FIFO, first in, first out. So we need to return the first element that was introduced into the queue. So we are going to do this by putting here QItems. Let's access the items and let's access the first one. And the first one is always going to be the 0 element. But now we need to do several things. So let's say that we want to remove the last element of the queue. So let's say that we have just a 1 here and we want to remove this one. Actually, the queue in the next moment is going to be empty. So we actually don't need to have this array. So what we can do is that we can free this pointer. So, this memory in which we are storing the arrays, but the array is empty, so we don't need that. What we are going to do is that, okay, if the number of items -1 is bigger than 0, we are going to do something. But in the other case, which is the case I just explained, we are just going to free the items and we are going to set this to null. And don't worry, this is totally okay, because let's say, okay, now you deleted this, and let's say that you want to introduce a new element, you want to push a new element, you don't have anything. But remember, we have here the reallocation function, the realloc function, and we are setting this to 1 in case we want to introduce to one value into an empty array. So that's totally fine. But now the next thing is the following. So we need to reallocate the memory, because in this case, it's like something like, let me open a new one. Is something like this. Let's say that we have this, and these 3 values, and we want to delete this one. We have several issues here. So let's say that, okay, we delete this one, but when we try to reallocate the memory, let's say that we want to reallocate it to only have 2 spaces, you would say, okay, the values that you want are this one, the 2, and the 3. But actually, what the operating system will do is that it will remove the last space. It will remove this one. And this is a huge problem because we want the 3. So what we need to do is that, let me redraw this. We have the 1 here, the 2, and the 3. So what we need to do is that, okay, we are going to delete this element, and we are going to move this one here like this, okay, to the first place, and the 3 is going to move here in this place. So whenever we reallocate the memory, this space is going to be removed, but it's going to be totally fine because the data that we want is going to be here. It's going to be still in the array. So how do we do that? It is very, 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 very simple. So we can do the following. For int I equal to 0, I plus 1, this is important, I will explain it later, is less than the number of items. Let's increase this. What I'm going to do is that the items I is going to be equal to items I plus 1. So this is actually what I did here. Let me draw it bigger and better. So we have this, this, and this. So imagine that this is removed, okay? So we have here the 2, and we have here the 3. What we are doing is like, okay, I'm here in the index 0. I want to put the value, the next value here. So what I'm doing is that I'm taking the 2 and I'm putting it here. So now here I have a 2. Now I'm here. I want to put the next value here. So what I do is that I take the 3 and I put it here. So I put here the 3. And this is why I'm using here I plus 1, because I need to check that that I can access the next element. Because if I just put here I would be here and then I would be accessing the next element, but there's no next element, and this would give us a segmentation fault. So that's why it is very important to put here an I plus 1, because I know that, okay, I plus 1 is here, there's an element, but in the next iteration here, the I plus 1 is not an element, so we stop the loop. So having this, the next thing that we need to do is to actually reallocate the memory. So how do we do this? Again, it is this same thing. So let me take it and copy it. So we are going to copy all this. But now instead of plus 1, we need to subtract minus 1. And here, instead of this, we need to put minus 1. So once we've done all this, we need to also set this number, well, we need to subtract this number. So we need to say that, okay, the number of items in the queue has now decreased, is 1 element less. And finally, we are going to return the value that we took here. So here we're going to put first. And we have already finished with the queue, with the FIFO method, because now what we comes is the destroy, which is truly very, very simple. We need to first destroy the items, and then we need to destroy the actual queue, and finally we need to print the queue. And for this we can do for int I equal to 0, I less than the queue number of items I plus plus, we can printf, let's put here this, and we are going to print the actual element. So we are going to put here items I, and that's it. Now we are going to print a new line, and guys, we have actually finished with the queue. So we are going to create a main function in order to test that everything is fine. So let's put here int main, and this main is going to return 0, so there are not issues. And here we are going to include the q.h, not q, q.h, and let's start. So first of all, we need to declare a pointer, not sq, and this pointer is going to be initialized with the qinit function. The next thing that we need to do is to, for example, push chevron times. So we are going to push into the queue a value, and let's do this 4 times, 2, 3, 4, and on each time we are going to print. So we are going to put here queue print. So we print the queue and we can see how everything is working. So okay, we have pushed this. Let me put here a new line. And now we are going to pop the elements, and we need to see that we are popping the elements in the right order, because here we are pushing a 1, a 2, a 3, a 4, and we need to push, to pop the element in that order. We need to pop the elements in that order. So we need to pop the 1, the 2, the 3, etc. So for that, we are going to put here pop queue from the queue, and we are going to print the value that we are popping. So we are going to do this. We're going to put here pop, so we know that we are popping. And yeah, we do this. Let's copy all this. And yeah, let's call also the queue print, so we can see what we have in the queue. And I think we have finished. So now, since I have this makefile, which is truly very simple, like clean to remove, compile to compile, and execute to execute the executable. So let's come here to the terminal, and the next thing that we are going to do is that, okay, I am in the stack, I need to go to the queue, and okay, so let me clear, and let's just make, and as you can see, everything is working fine. So we can see that first we push here and we have a 1 in the queue, then we push a 2, we have 1, 2, then a 3 and we have 1, 2, 3, and finally a 4 and we have 1, 2, 3, 4. But when it comes to popping, we pop the first element introduced. So for example, here, the first element introduced, which was the first element introduced? It was the 1. So here we are popping a 1. But the cool thing about this is that after the pop is done, the queue contains the values that we actually want, which are the 2, 3, 4. So there is not any issue with the remaining values. And this is very cool. So we can do a bigger test by actually filling again all the queue. So let me put this, let me copy this thing. So yeah, now let's call make again, and you can see that although the queue is empty, we can still push elements. And if you don't believe me, instead of putting here 1, we can put, okay, this number. We can put, for example, yeah, starting from 4, then here this, and then here 40. So if we come here, you can see that the first element is 1, 2, 3, then this one, then this one, and then this one, and 1, 2, 3 is the first one popped. 4, 1, 2, 4 is the second one popped, and yeah. But the final test is with Valgrind to check if there is any memory leak. So for this, we are going to put Valgrind minus leak minus check equal full dot exe. And you can see that we have one error. So 16 bytes in blocks are definitely lost. I think that here in the test I forgot to put q destroy. But it's very useful that we have this, so you can see the error. So you can see that it is saying that, yeah, we have definitely lost 16 bytes in blocks, And here we are losing the queue ini allocation. We have done 16 allocs, 15 freeze, but we have lost that. So we can do this again. Well, we have to compile. Let me clear, okay, clear. And now if we execute the Valgrind again, now we don't have any kind of issue. So this is how you create a queue in C. As you can see, something very, very, very simple and very, very, very useful. And if you understood, give it a like, share, subscribe, and see you in the next one.